So again, I'm Mike Lettau. From my introduction, I think you probably recognize that I don't have a lot of experience in supply chain. So I joined the supply chain organization at MilliporeSigma about 3 years ago. And prior to that, I came out of e-commerce. I did a lot of analytics work. I led data science teams. And so a lot of this stuff is really new to me, which I don't think is a bad thing. I think we're learning a lot. And then I also have Alina, who's in the back of the room, who graduated from WashU. She got her PhD in biomedical engineering. And she also has very limited background in supply chain. So we're kind of both tackling this together, trying to understand how it all works and looking for opportunities to apply some either data science or analytics or AI or whatever. So who are we? And this is sort of the corporate slide that I had to pull out of the deck that they told me I had to say. So we are Merck. There's a German Merck and there's a US Merck. And in Germany and the rest of the world, the Merck that's in Germany is known as Merck. In the US and Canada, the Merck that you guys are probably more familiar with is known as Merck. So there's two Mercks. We both sell pharmaceutical companies. They're both large multinational corporations. It's very confusing. If you follow us on Instagram, there's like every day someone will misuse our brand or our name, and there'll be someone on Instagram explaining what it actually is. So anyway, MilliporeSigma is part of the Merck group, which is Merck Germany. That's the key to this. Okay, and then so what is MilliporeSigma? MilliporeSigma is a fairly large life science company. I think we're number 3 in the market. It's about $9.2 billion in sales. And I guess that the important thing about this, when you think about it from a supply chain perspective, is it's a complicated supply chain, right? We have 300,000 products. We have 100 distribution locations. And I think one of the things that isn't captured on this slide, which is really important, is that we have 3 very different types of customers. We have, a guy sitting in a lab who's going to order a vial of something. We have someone in industry who may order like 20 vials of something. And then you've got a pharmaceutical company which may order like a tank truck of something. And we have to support all of those people or all of those markets with a single supply chain. And it's super complicated. And it doesn't map super well to like when you look at sort of the academic papers on supply chain and what demand curves look like and stuff. It does not look like the sort of the classic supply chain stuff that you read about. So to prepare for this talk, I started watching a bunch of YouTube videos because I still struggle with this idea of like what AI even is. And I think what I learned from watching all these YouTube videos on AI and supply chain is that there's a lot of definitions out there, right? And I think a lot of people, I think that the definition of AI has really changed over the past few years. It's gotten much, much broader. And it used to be like, if you go back to the classic definitions, it was like, it's when a computer can mimic human intelligence, which sounds cool, right? I mean, it's seeing things and understanding them, and it's being able to write. I mean, it's things like that humans can do. But what humans can't do is the thing that AI can do really well, which is to take huge amounts of data and to make a decision with it. So a human is never going to be able to take 8 billion rows of data and make a good decision. But that's exactly what AI is doing. So when I think about AI, okay, first of all, it's not spooky. There's a lot of people that are out there talking about how it's going to end, jobs and be super disruptive. I don't think it's going to be super disruptive, and I'll talk about why later. And then it's also not magical. I don't think that, when you sit up here and you see all these cool things that people are doing, I don't know if if you can just take what people are doing and drop it into your world. I think it's really that you need to figure out how these tools will work within your world and within your data. So it's a lot of work, and it's not easy. I think what we've learned over the past few years is that it's a lot of experimentation, it's a lot of testing, and a lot of the things that you think are such cool ideas that should work, they don't work. And the other thing that's on here that's super important is change management, because what we're doing is we're making changes to processes that people are really committed to and invested in, right? If I tell the demand planner that I'm going to change our forecast or I'm going to change their safety stock, I mean, they'll freak out. They get really nervous about that because that's what they're being measured on. So you really have to do a lot with change management, and you really have to be sensitive to the people that are being affected by the changes that you want to make. And so I thought this was interesting too. Just that, well, the one really interesting thing about this is that ChatGPT was launched less than 2 years ago, which just seems incredible when you think about the amount of press and interest that it gets. But you can see from this, that starting in 2022, it's gone up pretty. Or the searches for supply chain AI have gone just straight up. And that's, I suppose it's related to ChatGPT. There's just been so much interest in it. But I was listening to some of the YouTube videos, and they were talking about a lot of this may just be fear of missing out. Everybody thinks that everybody's doing it, so everybody wants to do it. And so there's a lot of pressure coming down from the top of the organization saying, you've got to do this because everybody else is. And I don't know if that's true. I'm not sure where people really are with all this, but I thought it was an interesting idea. Okay, so this is really interesting to me too. So a couple points on here. One is that just how incredibly powerful computing has become in the past, I don't know, since this from 71 to 2021, so in 50 years. But you've gone up by like 1 million times. So you've gone from 10,000 to 10 billion, so 1 million times more powerful. And then on the other side of this, you've got the price of computer storage, and it's gotten 1 billion times less expensive to store data. So there's a huge amount of data right now that's out there and available to work with, right? And you've got incredible amounts of processing available and out there to work with. And so like I said, I'm new to supply chain, and when I first joined, I took an MIT, like an online MIT course on supply chain analytics. And these are the equations that I was taught. So this to me was like, is this like state of the art for supply chain? So for forecasting, they taught Holt Winters, they taught exponential smoothing, and then for safety stock, they taught that equation. But what's amazing is that these equations were developed 60, 70 years ago. These are what we're using today inside of our supply chain. So then you think about, you've got 1 million times more processing since then. You've got 1 billion times more ability to store data, and yet this is what we're using. And it's like, there's something wrong there, right? It just doesn't feel right. It feels like there's gotta be a better way to do this. And then the other thing that I put this down there, our systems still use monthly aggregates to make decisions. I mean, when our supply chain systems were set up probably in the 70s or something, they aggregated data up to monthly aggregates. And so monthly aggregates are terrible for machine learning because you're just basically, washing out all of the detail that you need to make better decisions. But it's like, that's what we're stuck with today. Our systems are set up on that, and that's what we're using. So, I don't know, I just thought this was really interesting. It's like, so much has changed in 60 years, and these are still the equations that we're using. It just doesn't make sense. So today, I just wanted to go through a couple practical examples. I mean, we've got some examples on demand forecasting, and then safety stock calculations. We've been doing a lot with safety stock. Because there's been we got a lot of feedback about problems with our safety stock calculations. So we started looking at those. And then if we have some time, we'll go through thoughts on organizing resources, and then just some history that we have about failing and succeeding, and it's kind of cool. Okay, so forecasting. So traditional forecasting is done, and I'm pretty sure everybody's probably doing this too. I don't know how many people are really getting into multivariate forecasting at this point, but forecasting is traditionally done on order data or on demand data. And then you're just looking at historic demand data, and you're just predicting demand into the future with that data. I mean, it's a very simple approach. It allows for simple equations. But when you think about the data that's available today and how much is out there and the processing power that you have, I mean, you should be taking advantage of that additional data, right? I mean, there's gotta be more value in data that's around you rather than just orders. And then the other thing that's happening today is that we always think in sort of deterministic terms. When you develop a forecast, like if I want to figure out the forecast for like December, how many units I'm going to sell in December, generally a forecast is going to generate one number. It's going to be like, you're going to sell 20 units in December. But that isn't really, I mean, with modern forecasting and with the stuff that's coming out now, you've got two things happening. One is you've got multivariate forecasting. So you've got the opportunity to bring a lot more information into a forecast, which is cool, right? Because you want to capture, you want to have as much information as possible to make your forecast. And the other thing that you're getting are probabilistic forecasts. So you're not just getting a single number, a single point in time. You're also getting a range of potential outcomes. So it's like, instead of saying that we're going to get 10 units in December, we're going to get anywhere from, you know, maybe it's 8 to 11. Like, you're really confident in it. Or maybe it's 1 to 20. You know, it could be something you're not confident in. And when you have that sort of information, you may make a very different investment decision about your inventory. So I think it's just, again, these are sort of emerging ideas. I think that a lot of the new forecasting algorithms that are coming out are able to take multivariate data source or multivariate data and generate probabilistic results. And so I just had an example here. This is a project that we've had out for, I think it's been running for a few years now, but it's called demand sensing. And demand sensing is what we do when we can't really generate a forecast. We don't have enough demand history to actually generate a forecast. So what we did is we brought in other data sources to help us. So what other information could we use to predict whether something is going to sell if it doesn't sell very frequently? And so for items that are selling, you know, a few times a year, it's really hard to come up with a forecast for those items. But what we can do is look at it probabilistically and say, you know, there's an X% chance that this stuff is going to sell, and if we think there's a 60% chance it's going to sell within the next 3 months, we can make a decision then on whether we're going to stock it or not. And so in this example, we brought in inventory history, we brought in all these web behaviors. So we have a huge website, which is super valuable to us. So we can look and see how people are interacting with these products online. And from those interactions, even if they're not ordering them, you can learn a lot about their potential to order. You know, if someone's looking at the price, if they're looking at availability, if they're looking at technical documents, those are all really good indicators that something is going to be ordered in the future. So we use that a lot. And then order history, yeah, that's just, we throw that in there too. And then from all of those inputs or those features, we generate machine learning models which come up with probabilities. But this is I wanted to make this point too, because I think this is super cool. So when you're managing, you know, you're always managing your level of inventory. You know, you don't want to have, there's times in the business cycle where you want to be very aggressive with your inventory, and there's times when you really want to pull back. And the really cool thing about probabilities or probabilistic models is that you can actually adjust. You can just dial it up or dial it down. So like, and over the years, we've done this multiple times. When China was like, you know, our business is slowing, we need to pull back, we can just dial back the model and it'll start to reduce the inventory in China. When there was another period too when we were cranking things up, can't remember when, but we've also gone the other way on it. But I think that's a really cool idea, that you can just kind of turn a knob or change a threshold and you can bring in inventory or take it away. And so this is the other thing. This is Alina's slide, but I guess the point of this slide was just that there is so much going on in forecasting today. You know, and we have these simple methods that have been around. The traditional methods have been around for a while, but all of this stuff, these machine learning methods are new. And what's really cool is when you look at the years that these have come out, most of this stuff has come out, or a lot of this stuff, like AutoML is really new too. I don't think that's been, I mean, it's been around, but it hasn't been effective until recently. But a lot of this stuff has really been accelerating in development over the past couple of years. So it's just cool. There's a lot of opportunity here that I think, you know, you need to be thinking about, and hopefully you're able to take advantage of it. Another one that's down here too, so Times FM. So we have a really good relationship with Google, and we work with their consulting team a lot. And so maybe, I think it was like last summer, we did a project with them where they came in and they took our data, and then they basically ran a bunch of algorithms and tests against our data to see if they could, to see if they can prove some of the things that they're working on. And one of them is called Times FM, and the idea of Times FM is it's like when you think about like Gen AI models where they, you know, you're looking at patterns of words or or something. They're also looking at patterns of demand, and they're using that to create the model. And then the model is predicting or forecasting based on the historic demand patterns that it's seen. But it's super cool, and that hasn't come out yet. But I think, I guess what I learned from that is that there's just a lot of opportunity coming up. The other thing I learned from this, which I thought was really cool, is that the way that Google works when they came in, everything was an experiment. They were very, very disciplined. You know, everything was like kept in a notebook. It was just like just like how a chemist works or a biologist. There's like a lab notebook. There's experiments that are run. They mark everything down. And then in the end, they're always learning, and they're always kind of optimizing and moving forward. I thought that was pretty cool. The next one is safety stock. And so safety stock is pretty interesting. I mean, I've been working on this one for a while, and I think it's one of those things that I think there's a huge opportunity. There is a huge opportunity. I'll show you why in a second. But we were getting a lot of feedback from, I had complaints on there, and then Alina told me to take it down to concerns. But it was complaints from demand planners saying that these safety stock levels are too high, they're too volatile, they're causing problems for us. And so we started looking at what was happening with our safety stock, and there's a few issues with this equation. And again, this is the 1950s equation that we've been using for 70 years. But one of the big problems is that it assumes a normal distribution. And like I mentioned in the beginning, we have multiple markets that we're trying to serve at the same time. So our data, our demand distributions just don't look like other people's demand distributions. I think, and another one this was sort of stumbled onto this, but there's a huge cost in trying to achieve a certain service level. And I don't know if you guys do the same thing. I mean, we have like a goal of hitting 97% or 95%, and we set that goal and we calculate our safety stock to that goal, but we never look at like, what would happen if we dropped it down to 96? You know, what is the cost of moving from 96 to 97? Is it really worth that investment? And that turned out to be a really big deal, which I'll show you in a second. And then so for us, because we have long lead times, we have the 50%, it says in some countries 50% of total inventory is dedicated to safety stock, but that's in Australia. So we've got long lead times, we've got a lot of variability in the lead times, and we've got variability in demand. So all those things kind of come together and generate a 50% lead, or 50% safety stock. But that's a huge amount of money to be investing into a market. Oh, this also gets back to the what Eli presented about the digital twins. I mean, I didn't call it digital twins, but this idea of using simulations to calculate fill rates at various levels. And so what this is that we've developed this simulation thing, which basically allows us to simulate what the impact of different safety stock levels would be. And so what this graph is showing is like, if I have 0 units of safety stock, I'm gonna get like 55% fill rate. If I go to 100 units, I'm gonna get 90-something% fill rate. But what's really interesting is this is a very common pattern, is that these lines, these fill rate curves, they flatten out. And so they flatten out very rapidly. And so what you're seeing with this is that, we can get 95% fill rate with 54 units, so way down there. And then we can get 99% with 108 units. So double the safety stock gives us an incremental 4% of fill rate. And the question is, would you do that? Does that make sense? Is it worth doubling your safety stock to get to that point? And I mean, generally it's not, right? You don't want to be spending, there's probably much better places to invest your inventory than moving up from 95 to 99. So then what we did is we started looking at running these outcome probabilities through an optimization algorithm. And what this shows, I mean, I stole this chart from an old presentation, so I'm not really even sure what it represents. But what the current one that I'm working on I'm trying to set up an experiment right now with Japan. And when I ran the numbers and looked at the models, and I think it's really solid, right? I think it's a really good test. And it looks like we'll save about 30% in safety stock by running this optimization. And the idea of the optimization is just that don't focus on a single point outcome. Don't focus on trying to hit that 97%. Just have a little bit of flexibility. You know, if you move, like, for example, if maybe you may save a ton of money just by accepting the idea that you could drop it to 97 or 95 or 94 or whatever, but you need to have that flexibility. And when you do have that flexibility, running the optimization, we ended up with a 30% decline in the required inventory. Now, I haven't tested this yet. I set this up a couple weeks ago, and then I went to the demand planner in Japan, and I showed her, this is so typical too. So I'll have a list of 1,000 products, and there's maybe 2 or 3 where it just had a dramatically lower suggested safety stock. And she looked at those and she said, no, this is wrong, these won't work. And so now it's like I've got to go back and prove to her that, yeah, this will actually work, and we need to think about this holistically across the portfolio. But again, it comes back to that change management issue, which is like, if I want to make a significant change anywhere in the world, I've got to work with that person in that location. And I mean, we've run experiments in like Korea, China, all over APAC, and it can be really challenging to communicate with the operational people to convince them that the things that we're trying to do are okay, or they're not going to negatively impact what they're doing. I mean, there's language issues. It's really tough, but it's a big part of what we're doing. When you talk about implementing AI, the change management part of it is huge. I mean, I spend probably more time doing that than the technology side. And the other thing about the technology side is there's always an answer. I can go to Google and I can Google something and I can get an answer. When you're dealing with like change management stuff, it can be really tough to come up with a good solution. So that's safety stock. And then just some learnings. When I worked, I'm trying to think of what year this was, maybe 2015 or so, so I guess it's 10 years ago. But there was a lot of debate about where you put analytical resources or data science resources within the organization. And at that time, I think it was decided like we should centralize all of our resources. And it's funny because like you look at my title, which is Principal Analytics Architect, the reason it doesn't say data science in it is because politically, we couldn't have data science resources within supply chain. They had to be centralized when I was getting, so that was only 3 years ago. But I think what I've learned from this experience is that you want to put your data science resources and your analytics resources as close to the operational people as you can, because this is very much it's a cooperative effort, right? You can't have someone build a model and throw it into the operations and expect it to work. It just does not happen. You've got to get there and sell it. And so I think this has been really successful for us. And this is our team too. It's a really small team. I mean, we've got Alina, but Alina's she's got like a PhD. She's really, really smart. So it's like, we have only 2 people, but we're able to get a lot done. And we've got our intern too, who's pretty good. And so just to summarize these ideas, I mean, these are the arguments of those 2 approaches. You know, the why centralized? There was always this thing like all of our data scientists want to work together, they'll learn from each other. I don't know if that's really true. I think what is important though is you want to feel like you're having an impact, and you want to feel like you have ownership. A data scientist wants to feel like they're having an impact and ownership, and I think that can be accomplished within this model of embedding the teams. We get a lot of pushback on our tools and our inconsistent processes. I mean, we don't align well with IT at all. We're always in a kind of a discussion with them. So I think that is a challenge for us. But the domain knowledge is super critical, right? I mean, the data that you're working with in supply chain is super specific. It's super complicated. It's not something that you're gonna like be able to bring someone in from the outside and have them learn it overnight. I mean, we've tried, internally, we've tried to work with our centralized data science teams and to give them problems. And it's so challenging because they don't understand the domain. They don't understand the data. There's a lot of like nuances and just weirdness in our data that has to be explained. So yeah, so I think the embedded teams approach is really much more effective. And then, okay, I think I talked about this a little bit already, but it's really important to test stuff. You need to get things into production quickly. And I think that we've sort of, we're working on a team now, which is supply chain advancement, which is really open to making changes in processes. We still have to convince people that it's going to work and that we need to make these investments and stuff, but they're much more open to making these changes. And I said even the work unit is an experiment. That's really important. Everything is a test. Everything's an experiment. There has to be really good metrics. You have to really think about how you're going to set up that experiment. So our experiments are always set up as disciplined testing control groups, so we can really see the impact. Because if you don't do that, there's always like this gray area that you're going to be arguing with people about, and you don't want to do that. You want to make sure that you've got a definitive answer when this experiment is done. So you've really got to put time in up front to do that. I thought this one was kind of funny too. So senior buy-in for testing an idea is less important than operational support. So I listened to all these YouTube videos, and they always talk about how important it is to get like senior buy-in. And I was thinking, like, I can't imagine a senior leader today saying, like, we're not going to try something in AI. I mean, they are not the problem. The problem is getting the operational people to say, we're going to change your process. We're going to, and then there's always like this feeling like they're going to be wiped out. Like the man planners always feel like they're going to get fired. But again, I think senior leadership is another problem. It's the operational people. Change management again. And then they really have to understand what you're doing too. I think this was a really, early on when I started running experiments, this happened in Japan too, where I set up this experiment, I ran it, I looked at the results, and like nothing happened. And I'm like, what the heck? Why did nothing happen when it's happening everywhere else? And then I called this guy who's like a senior leader in Japan, and I'm like, hey, what's going on? Why isn't this working? And he spent like a half hour explaining how like the culture in Japan is different and you don't understand it. And it was just kind of, and I look back and I think this is really funny. But what it really was is that the person who was supposed to be executing the experiment didn't understand it, and they decided to just ignore it. So instead of making the changes that we had asked them to make, they just didn't do it. So again, you really have to make sure that they understand why you're doing what you're doing.